Hi, my name is Michael Utt, and I will be showing you my implementation of Programming Assignment 2, our RDT assignment. So just to start off, let me run the 2.1 server with the 2.1 local 2.1 client. You can see this works. If we go into our networks 2.1, we have byte corruption activated. And then if we come back to 2.1, you can see it translates to Pig Latin. That's jumbled mess and all. The server looks like this, like it's supposed to. We didn't change anything to the servers or the clients, at least not much. I increased the timeout time because I was having a hard time getting things to work together because I would take too long. Oops. Let me go over to the rubric over here to make sure I hit everything. We deliver data under no corruption in the network. Um, yeah, we have corruption in the network. I showed you that. We used a modified packet class to send ACKs and NACKs. If we come up to our packet class here in RDT, we have two new static methods, the isAck and isNack, and we have to add that. And we come back to 2.1. Is that 1.0? Yep, it's 1.0. It'd be nice to have two screens here. All right, look at the rubric one more time. I showed you I used a modified pack. We do not deliver corrupt packets. We use modified packets to send NACs for corrupt packets. I'll show you all that in the code right here. So send here, we send the message. We wait for a response confirmation. That's the first thing that we wait for. We wait for an ACK or a NACK. And then from there, we read this ACK or NACK. And we get the byte buffer set. We have our receive packet. And we get this as a packet itself. And then we can see if this packet is an ACK, we can increase the sequence number and break out of this loop. If it is a NACK, we have to reset the byte buffer, and then we just continue through the loop, which will send it again and wait for another acknowledgement or NACK. Here on RDT 2.1 receive, we do the same thing that we do in 1.0. And then here's the 2.1 part right here. We check if the byte is corrupted. If it is, we create a new packet with a NACK, and we send that NACK back over. Otherwise, if it's not corrupted, that's great. We send an ACK, and then we carry on sending this message. Otherwise, you see if it's a corruption, we return out like we do if it's not long enough or it's just the way to get out. All right, now I will show you 3.0. Let me open up this console one more time. So if I do this is 3.0, yep, 3.0.py, and then I'll go up to 3.0 for the client. So here's the server and the client. It looks the same because they are the same. I don't think there was anything that really got changed, at least majorly in those files. So I will close that back down. Move over to RDT 3.0. Here we come down, we see RDT 3.0 send. Let me show you my networks really quick that we now also have byte corruption and byte loss. I didn't do the reorder, I didn't do the extra credit. Let's go to the rubric. We deliver data under no corruption or loss in the network, and we use the modified packet class. We don't deliver the corrupt packets. We retransmit a lost packet after a timeout. We retransmit a packet after a lost ACK, and all those good. And we ignore a duplicate packet after a premature timeout. And I'll show you how I did that in my code here. So in RDT 3.0 send, we have our timeout right here. We would wait for a byte to come through. If it before in 2.1 we had this too, but we added this timeout mechanism. So if nothing arrives, it won't get stuck. But if it is empty, we will just continue through the loop and just send another message because we assume that they didn't get it. Now, if our byte is not empty, we check to make sure the packet is not corrupt. If it's corrupt, we have to, we just set the byte buffer back to nothing and we loop back through and we send it back again. But if the acknowledgement packet isn't corrupt, or the ACK or NACK packet, if the sequence number of it is less than the current sequence number, then that's a good thing. So we send an ACK. If it is an ACK, but if it's an ACK, we send a sequence number here. If the receive message is NACK, stay in the loop, which will resend this message, and that's kind of just keeps going through the loop here. You can see is NAC, loop through. If it is an ACK, we increase our sequence number and break out of this infinite loop. Sorry. Our 3.0 receive, here's everything that happened in 2.1 and 1.0, but now we also have to check sequence numbers. If we get a repeat here by the sequence number that we're receiving, this acknowledgement packet, if it's less than our current sequence number, then that's just a duplicate. So we'll send an ACK. If it's the same one, or if the packet received is equal to the sequence number, that's good. That means we just got the right packet in a row. Send an ACK, send the answer, increase our sequence number. Good to go. Our other scenario here is that if neither of these happen, we will, if uh, the sequence number is greater, which can't happen actually, and then if the packet is corrupt, we still send a NAC, of course. And that's how 3.0 works. Thank you for watching my video, and thank you.